6.5.
6.5. Is it 6.5? 6 or 7.5? Read the chapter's name. First chapter is numbers. Second chapter is numerical inequality, matrices, determinants, then application of derivatives, probability, then what's the next one? Index numbers, half. So total 6.5. Is it 6.5? Aishwarya?
Yes, ma'am.
Yes. So 6.5 chapters are there for the first term. Is it clear? So start revising. You have the textbook. We have completed almost all the chapters. The last chapter only we are doing. What you can do, you can start revising. Within this month, you should make it thorough what is given in the textbook. Application of derivatives and all we learned in the beginning. What you can do, you can start revising from your textbook. Each day, every day, you take one exercise and try to complete it. Okay. Okay, children. Now, we can start with what we are discussing yesterday. Yesterday, we did probability distribution function, isn't it? We did some questions from probability distribution function. Okay. Now, look at this, children. This is a textbook given by the handbook given by the CBSE, okay, NCRT. So here, probability distribution. Yesterday we discussed about random variable. What is a random variable? A random variable is a real valued function. It is a real valued function whose a random variable is a real valued function whose domain is the sample space of the random experiment. Write down this term also. A random variable is a real valued function whose domain is the sample space of the random experiment. It is a function. We can consider random variable as a function because it takes real numbers. We can take it as a real valued function. Okay. So now look at this example. Okay, listen, children. Today I'll share this booklet. Okay, I'll send it in your class group. Go through it. Now look at here, example 1. It is an example 1. One of you read this one. Karthik, read this one, Karthik. Example 1.
Rajat is playing a game of rolling a die with his friends. According to the game rules, he will win ₹5 for rolling an even number and for getting an odd digit on the die. He loses ₹2. If X represents the amount of money Rajat wins or loses, show that X is a random variable and also represent it as a function on the same sample space of the gameplay.
It is a function, isn't it? We have to prove it is a function. How to prove it is a function? Okay, here when we throw a die, we know that, okay, when we throw a die, what are the outcomes we will get? 1, 2, 3, 4, 5, 6. And what is given? Whenever we get an even number, he will win ₹5. So whenever he get an even number, he will win ₹5. Okay, so even number means he will win ₹5. So 2, 4, 6 will be mapped on to 5. And whenever he is losing, whenever he gets odd number, he'll be losing ₹2. So that means it will be mapped on to -2. So X takes only two values. Which are the two values X will take? +5 and -2. It will take two values, +5 and -2. Is it clear? Yesterday we discussed one question based on head and tail. Is that no? Similar question. Okay, similar question only here also it is explained. Is it clear? Is it okay? Aparna? Anila Mohanan?
Yes, ma'am.
Yes, ma'am.
Now look at the next one. Look at the next one. Next we discussed about the discrete. Okay, discrete and continuous. Discrete means what we discussed, only countable outcomes are there, means we call it as discrete. Continuous means suppose we are not able to count how many elements are there. Okay, look at an example is given. A wristwatch displaying the seconds. Okay, X denotes a random variable which displays the time shown by a wristwatch. So here it takes so many values. We don't know what are the values. So in that case, whenever it takes infinite values, we call it as continuous random variable. Next, we discussed about probability distribution function. Okay, look at this experiment. Now look at this, children. This is again another experiment. Okay, this one and all, go through it. You'll get some questions from this part and all. Let us consider a random variable x defined as sum of digits. Defined as sum of digits. Okay, we throw dice, sum of digits on rolling of 2 dice. We roll 2 dice and we are discussing about the sum of the digits. When you roll 2 dice, what are the possibilities? The first die you will get 1, 2, 3, 4, 5, 6. Second die also will get 1, 2, 3, 4, 5, 6. So what are the possible sums? You will get 1 plus 1, 2. 1 plus 2, 3, 4, 5, 6, 7. Or first die you may get 2. Second die you can keep on varying. So sum will be 2 plus 1, 3. 2 plus 2, 4. 2 plus 3, 5. Like this. You fill this table. So what are the different sums you will get? You will get sum 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now we are writing the probability distribution. So what is the probability to get sum 2? How many times we get 2? Look at here. Only one time, isn't it? So 1 by 36. What is the probability to get sum 3? 3 plus 3. 2 times are there. So 2 by 36. Sum 4, 3 by 36. Sum 5, 4 by 36. Sum 6, 5 by 36. Sum 7, 6 by 36. Again sum 8, 5. Sum 9 is 4 by 36. 3 by 36, 2 by 36, and 1 by 36. This table only we call it as probability distribution table. Yesterday we discussed about this, how to construct this probability distribution table. Is it clear? Go through it. Is it okay? Are you able to understand this one? Any doubt in this part? Aishwarya, is it okay? Any doubt?
Yes, ma'am, it's fine.
Okay. Aparna, Femina?
Yes, ma'am. It's
Shall
okay,
I,
ma'am.
okay. So shall I move on to the next slide? So this is what we discussed yesterday, how to frame a probability distribution table. Now look at the next one. This part I gave us homework yesterday. How many of you tried it? I don't know. A similar example is given here. A coin is tossed thrice and the outcomes are recorded. Find the probability distribution of the number of heads. Yesterday we did this in a different way. Is that no? Okay, when 3 coins are tossed, what are the outcomes? It will be 0, 1, 2, 3. Okay, when a coin is tossed 3 times, we'll be getting, okay, 3 times. So we may get 3 head, 2 head, 1 head, or 0 head. Suppose it is 3 head, then what are the possibilities? 3C0 into all are tail. 1 by 2, 1 by 2, 1 by 2. 3C0 is 1 into 1 by 8. Now look at the next case, x is equal to 1. See this calculation and all, it is not explained there. X is equal to 1 means only 1. So 3C1 into only 1 head, the remaining are tail. P of t into P of t into P of t. So we'll get 3 by 8. Next is 2 heads. 2 head means P of x is equal to 2. Then 3C2. There we write 3C2. Then we write 3C3. Is it okay? And here you noted down the probability distribution. In a probability distribution, sum of all probabilities is always 1. Sum of probabilities is always 1. This is what we discussed yesterday. Is it okay? Now we are going to start with the next one. Write the heading. Mathematical expectation of discrete probability distribution. Mathematical expectation. Mathematical expectation. Okay. Now listen, children. Suppose x be the random variable. X be the random variable whose outcomes are xi. Okay. Whose outcomes are xi and the probabilities are pi. Whose outcomes are xi and the probabilities are pi. Whose outcomes are xi and the probabilities are pi. So now listen children, we are going to learn few terms here. Okay, so the expected value or expected value, sometimes we call it as expectation. Expectation, or okay, it is sometimes it is otherwise called mean. We denote this as E of x. E of x, which is equivalent to, okay, mean or E of x. We denote this as mu. All these notations are equivalent. Expected value or expectation of the random variable or mean, and we denote this as, sometimes we denote this as E of x. Expected value means we denote it as E of x. Mean means we denote this as mu, and it is given by sigma xi into pi. Sigma xi into pi. Mean is given by sigma xi into pi. Okay, so you can note it down. E of x is equal to sigma xi into pi. Okay, so write this note. E of x is sigma xi into pi. Now the second point, E of x square. What is E of x square? Sigma xi square into pi. Look at the notations, children. E of x square means sigma xi square into pi. So the third one is a very important formula. Third one, variance. Last year we have learned how to find variance. We know the formula in statistics we have learned variance. Okay, here also we are going to learn variance. Variance is given by sigma square. It is equivalent to E of x square minus E of x, the whole square. E of x square minus E of x, the whole square. Variance, we denote it as sigma square, and it is given by E of x square minus E of x, the whole square. And the next one, fourth one is standard deviation, SD. Standard deviation. Standard deviation, SD. We denote this as sigma. This is same as square root of variance. Standard deviation is square root of variance. Standard deviation is square root of variance. Variance of x, sometimes we denote like this also, VAR of x. We denote like this, VAR of capital X, variance of capital X. Variance of capital X. Okay. So the variance is given by E of x square minus E of x, the whole square. And square root of variance is the standard deviation. Square root of variance is the standard deviation. Okay. Square root of variance is the standard deviation. Is it clear? Is it okay? You have learned so many formulas. Okay, learn the formula. Go through it. What is the formula to find expected value? E of x is given by E of x is given by sigma xi pi. It is otherwise called expected value. Mean, we denote it as mu. Variance is given by E of x square minus E of x the whole square. How we have to find E of x square? E of x square is sigma xi square into pi. Sigma xi square into pi. Okay? So now we'll take your textbook. Take the textbook. Exercise 9.2. Exercise 9.2. Take the question. Now, if you read the question, Aditya Satyan, read the question. Exercise 9.2, first one.
A boy throws a coin. He is to receive 2 rupees for getting a tail and 10 rupees for getting a head. Find his expectation.
So, if he gets one head, he'll be getting how many rupees? 10 rupees. And if he gets a tail, he'll gain 2 rupees. Okay. What is his expectation? So, I'm going to denote, X denotes number of heads. Okay, sorry, not here. It is not X. What is the question here? We want to find on the amount he received, isn't it? So, X denotes amount he receives. How much amount he will receive. So, what are the possible amount he will receive? He is throwing the coin. One coin only he throws. So, for one head, he will get 10 rupees. Or if it is tail, he will get 2 rupees. So, this is the value of X. Now, write the probability distribution. Write the probability distribution. X, P of X. So, when X is 10, what is the possibility to get 10 rupees? What is the possibility to get 10 rupees? How many times? 1 out of 2, isn't it? 1 by 2. 2 outcomes are there. So here 1 out of 2. And 2 rupees 2, that is also 1 by 2. What is asked here? We are asked to find E of X, isn't it? What is E of X? We are asked to find the expected value. E of X is sigma xi pi. So I'm writing another column, xi pi. What is xi pi? You multiply these two and write 10 into 1 by 2, which is 5. 2 into 1 by 2, which is 1. Next is sigma xi pi. Add these two. It is 5 plus 1, it is 6. Is it okay? How we find the expected value? Is it clear? Expected value is sigma xi pi. So first we construct the probability distribution table. Along with the table, we add one more column. This is the new, okay. This is xi into pi. We multiply the corresponding value of x with its probability. Then we add up sigma xi pi. Is it okay? How to find the expected value? Is it clear, children? Is it okay? Is it clear? Is it okay?
Yes, ma'am.
Yes, okay. What about the others? Any doubt? Aparna, Karthik, Femina?
No, ma'am.
No, ma'am.
Shall we move on to the next one? Yes. Yes, Femina. Now look at the next one. Second one. This is one more question. Look at this question. Read the question. A game at a school fair cost rupees 10. Okay. For a game, we have to pay 10 rupees. With the price of rupees 50, you have to pay 10 rupees. If you win, you will get 50 rupees. Okay, with a price of rupees 50. The probability of winning a prize is 1 by 10. Is it a fair game? What is your answer? The probability of winning a game is 1 by 10. Is it a fair game? You have learned this in 10th standard, 11th standard, mutually exclusive, exhaustive. While discussing all these things, we have learned about a fair game and all. What is meant by a fair game? When you say game is a fair game, look at here. What is the probability of winning? 1 by 10. Is that no? So what is the probability of losing?
9 by 10.
So is it a fair game? When you say game is fair game, when you toss a coin, you may get a head or you may get a tail. Okay, so the chances are equal. Is that no? Equal chances. Okay, the probability of winning is same as probability of losing in when we toss a coin. Here is it like this? Probability of winning is 1 by 10, very less. And what about the probability of losing? 9 by 10. So probability of losing is more. If the probability of winning is same as probability of losing, then we say it is a fair game. Here, it is not at all a fair game. Is it clear? We'll get some questions like this. Okay, if you toss a coin, it is okay. It is a fair game. If you throw a die, listen children, these are all some important questions. Important questions means in the sense you have to think and answer. Suppose we throw a die. Success is decided by getting an even number and failure is decided by getting an odd number. Is it a fair game?
Yes.
Will it be? Yes. Both odd and even number, if you take it, the probability will be 3 by 6, 3 by 6. Now look at this second case. Okay, the same case. Suppose I'm throwing a die. Getting a number more than 5 is considered as success. And getting a number less than 5 is considered as failure. Then, is it a fair game? No, isn't it? We are getting a number more than 5 means only one chance is there, 1 by 6. Getting a number less than 5 means 4 by 6. So it is not equal. Whenever the probabilities are not equal, it is not a fair game. Is it clear? This one, we have learned it in our lower class. Based on that only it is asked. Okay. So second one, you can explain. Now third and fourth one, you can do it as homework. Third and fourth one, we can do it as homework. Now let us do the fifth one. Look at the fifth question. Read the question. The probability distribution of a random variable x is given below. The probability distribution of a random variable x is given below. X is given along with p of x is given. And look at the values given here. 0.5 k, 1 k square, 1.5, 2 k square, 2 k. What we have to find? First one is find the value of k. First one, you have to find k. Second one, we have to find mean. Find mean. Okay, you write one more part. Find variance. So that the next one and all you can do. Find variance. Okay. We have to find out all these things. Find k, find mean, find variance. Okay. So I'm going to find k. How will you find k? How will you find k? What we know? To find k, how will you do this? Sigma pi. Yes?
Sum of all the probabilities 1.
Yes, sigma pi is 1. When we add this, what you will get? Look at here. 3k square plus 2k is 1. So we'll get 3k square plus 2k minus 1 is 0. Now split this. So it is 3k square plus 3k minus k minus 1 is 0. We are solving it by using splitting the middle term. So here if you take 3k outside, you get k minus 1. Again, if you take minus 1 outside, k minus 1 is 0. So we get 3k, sorry, it is k plus 1. 3k minus 1 into k plus 1 is 0. So k is equal to 1 by 3 or k is equal to minus 1. Look at your children. K is equal to minus 1 is not possible. Why? Probability will not be negative. Okay. So k is equal to minus 1 is not possible. Okay. K is equal to minus 1 is not possible. Therefore, what is the value of K? Possible value of K is 1 by 3. Is it okay? Possible value of K is 1 by 3. So K is 1 by 3. Okay. Now, once we find K, look at here, I'm drawing the table once again. Okay, once we find K, I'm writing this table. Okay, I'm redrawing the table. X, P of X. Because if you have the table, you can find it easily. K value is 1 by 3. 1 K square. K square means it will become 1 by 9. 1.5. What is 2K square? So it will be 2 by 9. 2, it is 1 by 3. Okay, you can check this. When you add this, are you getting 9? Yes or no? Are you getting sigma? Pi is 1. Okay. Now what is asked? The first thing you are asked to find is mean. What is the formula for mean? Sigma xi pi. So I'm writing one more column here. Xi into pi. You write one more column. Xi into pi. So it will be xi into pi 0.5 into 1 by 3. So it is 0.5 by 3. Next is 1 by 9. 1.5 into 2, which is be 3 by 9. This is again 2 by 3. Okay, now add up all these values. Add these values, you will get what is mean. So mean will be 0.5 by 3 plus 1 by 9 plus 3 by 9 plus 2 by 3. Simplify this and check what is mean. Find out what is the mean value. If you want, we can take the LCM here, isn't it? Simplify and check the answer. Is it okay, Femina? Is it clear, Femina? Finding mean?
Yes, ma'am. Yes, ma'am.
What is sigma xi pi? Add and give the answer. We can take the common LCM as 9, isn't it? We can take the common LCM as 9. You take the common LCM. Sigma mean is sigma xi pi. So it will be 0.5 by 3 plus 1 by 9 plus 3 by 9 plus 2 by 3. If you want, we can take the common LCM as 9. Here you can multiply by 3. Here also we can multiply by 3. So 3 into 0.5 means, what is 3 into 0.5? Aparna?
Ma'am, 1.5.
Yes, 1.5 plus 1 plus 3 plus 6. So what you will get? 9, 10, 11.5 by 9. Is it correct? If you want to remove the decimal, we can multiply it by 2. So we'll get 23 by 18. Mean is 23 by 18. Next thing we want to find is variance, isn't it? For finding, yes.
You just have to give that in the fraction form.
Yes, you can write in a fraction form. That is enough. No need to convert in decimal. You can write in fraction form. Okay, in MCQ, suppose they give in decimal, you have to convert. Otherwise, fractional form, we stop with fraction form only. Usually we stop with fraction. Okay, it's being MCQ. Sometimes if small numbers means they will give in decimal. Otherwise, usually we will be getting the answer in fraction itself. Okay. So what is variance here? E of x square minus E of x the whole square. We want to find E of x square. What is E of x square? Sigma x square into pi, isn't it? So here I'm going to write one more column here. X square. What is xi square? Look at then. What is xi? What are the values of xi? What are the values of xi? Look at here 0.5. When you square it, if you want to avoid this, we can take this as 0.5 means 1 by 2. Okay, calculation will be easy. You can convert it. 0.5 means we can write it as 1 by 2. So it will be xi square. It will be 1 by 4. 1. If I square it, 1. 1.5 means it will be 3 by 2. So when we square it, we'll get 9 by 4. Again 2, if you square it, it is 4. So the next column is xi square into pi. Xi square into pi. So 1 by 4 into 1 by 3, which is 1 by 12. 1 into 1 by 9, which is 1 by 9. 2 by 9 into 9 by 4. So what happens? 9 will get cancelled. So it will become 1 by 2. Again, the next one is 1 by 12. Am I correct? Check this. Okay, check this answer, children. So next we want to find sigma x square into pi. That is 1 by 12 plus 1 by 9 plus 1 by 2 plus 1 by 12. I think the common LCM you can take will be 36. So here you multiply by 3. Here multiply by 4. Here again you can multiply it by 18. Again multiply by 3. So we get 3 plus 4 plus 18 plus 3. So 3 plus 4, 7, 7 plus 3, 10, 10 plus 18, 28 by 36. Simplifying, we can write this as 14 by 16. Is it correct? 14 by 18. Then, which is 7, same as 7 by 9. So this is E of x square. So what is variance? Variance is E of x square minus E of x the whole square. So we get 7 by 9 minus, what is E of x square? Earlier we calculated this as 23 by 18, the whole square. So now expand it and simplify. Expand, yes.
Xi square pi, that one's last column. Isn't it 4 by 3?
Xi square is 4. Okay, I wrote that as 1 by 12, isn't it? I think 4 into 1 by 3 I did. Xi square is 4. 4 into 1 by 3 means pi is 1 by 3. Yes, we'll get 4 by 3. Okay, then everything will change. Yes, correct. Is it correct? 4 by 3? Karthik? 4 into 1 by 3, isn't it? I think I multiplied.
Yes,
So everything will change. Yeah. Plus 4 by 3. So you can multiply it by 1 by 12 plus 1 by 9 plus 1 by 2 plus 4 by 3. Again, you can take the common LCM as 36. So 3 plus 4 plus 18 plus 12 fours are 48. Is it correct? So it is 7 plus 18. It is 25 plus 48 by 36. So we'll get Is it correct? Check it. Check this, children. Is it 36? LCM is 36. When you add this, are you getting like this? So is it 73 by 36? Check your answer, okay? Then find out variance. Variance is E of x square minus E of x the whole square. So which is 73 by 36 minus 23 by 18 the whole square. Okay, so we have to simplify this. So what you can do, I think 73 by 36 minus 23 square. What is 23 square? Is it 529 by 18 square? What is 18 square? Then take the LCM, simplify. You'll be able to find what is the variance. Okay, what will be the variance? Complete it. How to find the variance? Check it. Is it okay? Okay. Okay, children. So calculation process you can complete. Now is it okay how to find the mean and variance? Is the method clear? Mean is given by sigma xi pi. And what about the variance? Sigma xi square into pi. Okay. So your homework is, note down, third one, fourth one, sixth one, 3, 4, 6, 7. 3, 4, 6, 7. You do it as homework. Along with few example questions also, you try that one. Okay, try few example questions. Okay, with this we conclude the session. Thank you.